Welcome. So this is if you like, the ending of the system by which we use components. Um, Typically, we will have a vector at some angle, and we will then find its x component and its y component. And the idea is we can then just arithmetically add up all the x components and then arithmetically add up all the y components. And we end up with an x component answer and a y component answer. And often that's enough, but sometimes we want to find the actual magnitude and direction of the resulting vector. And that's what we're going to practice here. So we've added up a whole bunch of x components and we've added up a whole bunch of y components. And we found that our final x component value was 6 meters. This is the displacement vector. And our y component was plus 4 meters. So we have our two components. And so we'd like to find the magnitude and the direction of the actual true resultant. And for the true resultant, let's visualize this first of all. Again, I like to have my own diagrams. I don't like to rely upon the teacher's diagram or the examiner's diagram, unless it does look really good. I like to use my own diagram. So that's the x-axis and that's the y-axis. And this is 6 meters long. So I'm going to go 1, 2, 3, 4, 5, 6. And this is 4 meters tall. That's 1, 2, 3, 4. So let's draw these guys in. So there's and this is 6 meters, and this is in the x-axis direction. And this here is 4 meters, and this is in the y-axis direction. And I want to try and construct from that my original my resultant vector. Well, the first thing I do is I draw a line perpendicular to the x-axis, and I draw a line perpendicular to the y-axis. And where they meet, that's the end of my resultant vector. And I have this as my resultant vector. So what I'd like to find is the length of this, and I'd like to find its angle relative to some convenient axis, and I'm going to use the positive x-axis here. So I look at this and I say, hold on, this is a right angle triangle. So the first thing I'm going to use is Pythagoras. I'm going to say r squared equals x squared plus y squared. Just Pythagoras' expression. So r squared is equal to 6 squared plus 4 squared. R squared is equal to 36 plus 16. R squared is equal to 4652. So R is equal to the square root of 52. So R is equal to, and I get my calculator, my simple calculator, and I'm going to say second square root. I've not got my glasses on. Second square root of 52 is equal to 7.211. So this is going to be 7.2 meters. It's a magnitude, so it's always positive. It's not a vector. So what I tend to do is if they're magnitudes, I don't bother with the positive sign because they always are positive. If they are, well, yeah, I suppose temperature is a magnitude and sometimes it can be negative on the number line. It's an address. If it was a vector, I'd definitely try to remember to put a positive sign there or a negative sign if it was negative. But this is a magnitude. So I can just put down 7.2. In terms of the angle, well, let's mark where the angle is. Let's call the angle there. So now I say, oh, hold on. I know the opposite to this angle, which is 4 meters. and I know the adjacent, which is 6 meters. So I can say, oh, tangent of this angle equals opposite over adjacent. So the angle equals inverse tangent, tan to the minus 1 of the opposite over the adjacent. So my angle is equal to tan to the minus 1 of 4 over 6. So theta is equal to, and again, just looking at my calculator briefly, I'm going to go second tangent, and I'm going to go 4 divided by 6, close my parentheses, and I get 33.69, which is 33.7, which is 33.7 degrees. And so I look to the side, I'm looking for 7.2, but with 33.7 degrees. So there's my choice. This methodology of breaking a problem into components arithmetically, adding all the components. So you end up with a resultant x component and a resultant y component. And then using simple Pythagoras and using a simple trig to get the magnitude and the angle of the direction of the resultant is a very standard process. We're going to use it all through Newton's laws and the like. We use it as a background skill. And so we have to quickly get to the stage where we're not struggling with this, but we're very comfortable with this. So practice, practice, practice. We'll make this go better. And there we have it.